This is the 4.8a video on complex numbers. So number one, you're subtracting two binomials. So you want to distribute the negative in the parentheses. So we have 12 plus 5i minus 2 plus I. Add like terms. 12 minus 2 is 10. 5i plus 1i is 6i. And that's your answer. Number two, you're multiplying the binomials. So 8 plus I times 2 plus 7i. So we're going to distribute. So 8 times 2 is 16. 8 times 7i is 56i. I times 2 is 2i. And I times 7i, can do that over here. I times 7i is 7i squared. But remember, I squared is negative 1. So it's the same as 7 times negative 1, which is negative 7. Now we want to add like terms. 16 minus 7 is 9. 56i and 2i is 58i. Number three, we're dividing. We're not allowed to have an I in the denominator. So what we have to do is, as a general rule, multiply the numerator and denominator by the conjugate of the denominator. The conjugate is going to be 2 plus 3i. You're going to have the same exact terms but at a different sign in the middle. So when we multiply across, we're going to have 4 times 2 is 8. 4 times 3i is 12i. For the denominator, we're multiplying two binomials that are conjugates of one another. When you multiply conjugates together, you only have to do F and L in FOIL. So this and this, because the O and I in FOIL cancel. So 2 times 2 is 4. Negative times a positive is a negative. 3i times 3i is 9i squared. And remember, I squared is negative 1. So 4 minus 9 times negative 1. Negative 9 times negative 1 is 9. 4 plus 9 is 13. So our denominator is going to be 13. And there's our answer right here. Number four, find all the solutions to the quadratic. Let's just use the quadratic formula. So the opposite of b plus or minus square root b squared minus 4ac all divided by 2a. Let's simplify this. The opposite of negative 4 is 4. Negative 4 squared is 16. A negative times a positive is a negative. 4 times 2 is 8. 8 times 7 is 56. 15 minus 56 is negative 40. 2 times 2 is 4. We can leave it like this for now. Well, actually, no. Sorry. Well, we just found out about extracting i's. So let's extract this negative out. So we're going to have 4 plus or minus I root 40 all over 4. This is going to be our answer. Let's just get this out of here. Alright, number 5. Let's rewrite this. So we see that we have some square roots and negatives here. What we're going to do is we're going to take them and extract them out. When you extract it, it becomes an I outside of it. So I root 1 minus negative 3 plus I root 16. The square root of 1 is 1. So 8 minus 1I minus negative 3 plus root 16 is 4. 4 times I is 4I. So this problem becomes just like 1 in the beginning, like number 1. So let's distribute this negative in. So 8 minus I plus 3 minus 4I. 8 plus 3 is 11. Negative I minus 4I is negative 5I. And there's your answer. Number 6, we have a multiplication on the left. So let's multiply these out. So x times x is x squared. Now notice that these two binomials are exactly the same except for the middle sign. That means they're conjugates. That means we only have to do f and l in FOIL. So a positive 3i times a negative 3i is going to be a negative 9i squared. Remember that I squared is negative 1. So x squared minus 9 times a negative 1 is a positive 9. Now what we can do is we can subtract 9 from both sides. X squared equals 25. Take the square root of both sides. X is positive or negative 5. Number 7, here's a review problem. We need to graph this function. So this is a quadratic. We see that from the squared here. So the vertex, it's in vertex form. The opposite of negative 1 is 1, comma, negative 5. We don't take the opposite of this because it's not next to the y on the left side. So we can go ahead and plot this. So 1, negative 5 is right here. To find the y-intercept, we can set x to 0 and solve. So if we do that, it's going to be 0 minus 1 is 1. Sorry, negative 1. Negative 1 squared is 1. 1 times 3 is 3. 3 minus 5 is negative 2. So there's our y-intercept right here. The point that's symmetric to that would be right there. Let's just find one more point. Let's find out what 3 is. So let's plug in 3. So y equals 3 minus 1 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 5 is 7. So we have 3, 7. It's right here. And then a point symmetric would be here. So then we can connect these points. And there's your graph. Alright, number 8. They want us to use the quadratic formula, so let's get everything on the left side. That means we'll have to add 7x over, and then add the 8 over. So the opposite of b, plus or minus, square root b squared minus 4 ac divided by 2a. Simplify this now. Opposite of 7. The denominator is 2 times 1. 7 squared is 49. A negative times a positive is a negative. 4 times 1 times 8 is 32. 49 minus 32 is 17. And there's your answer. Number 9, they want you to complete the square. So 4x squared minus x minus 3 equals 0. First step, add the constant over. Next step, factor out the lead coefficient. Leave a space. Next step, take half of this, it's negative 1/8, and square it. That's 1/64. If you multiply now 4 times 1/64, you get 1. Sorry, my brain is like fried right now. 1/16. So we have to add 1/16 here. This is now a perfect square. So 4 parentheses x minus 1/8 squared equals. Let's make this common denominator 16. If I make 3/16, it's going to be 48 over 16. So 48 over 16 plus 1 over 16 is 49 over 16. Let's multiply both sides by a fourth to cancel this. So we have x minus 1/8 squared equals 49 over 64. Let's take the square root of both sides. So x minus 1/8 equals positive negative root 49 over 64. This is a perfect square fraction. So let's continue it up here. So x equals 1/8 plus or minus. The square root of 49/64 is 7/8. So the two roots is going to be 1/8 plus 7/8. That's 8/8. So that's 1. 1/8 minus 7/8 is negative 6/8, which is negative 3/4. So you have negative 3/4 and 1 as your solutions. And last, explain the difference between an additive inverse of a complex number and a complex conjugate. Alright, so we need to talk a little bit about what an additive inverse is and what a conjugate is. An additive inverse is something that if you were add something to an additive inverse, you get 0 out of it. For example, if you start with 5, the additive inverse of 5 is negative 5, because if you add them together, you get 0. An easy way to get an additive inverse is to multiply whatever you start out with by a negative 1. For example, if I have x plus 2, the additive inverse of that is the opposite of x plus 2. In other words, negative x minus 2. Because if you add x plus 2 to negative x minus 2, you get 0. A complex conjugate would be something like 3 plus 2i. The conjugate to that would be 3 minus 2i. So this would be a conjugate where you only take the second term and change the sign. Whereas the additive inverse of this would be the opposite of this. In other words, negative 3 minus 2i. That's the additive inverse. So again, the conjugate, you're only changing the sign of the second term. The additive inverse, you're changing the sign of both terms.